Hello students, welcome to Dr. Shourab's classes, and in this particular video you can know that we are solving the questions from UPSC, this maths optional paper. We are solving this paper 1 of 2021. Okay, so in the previous video I've solved that in the 6B, and that was quite explanative and elaborative. So now move to the question 6C, where you have to evaluate this integral f of dr. In this C is the arbitrary closed curve, so this is a closed integral in the xy plane, and f is given as minus yi plus xj by x square plus y square. Okay, so in the xy plane, so what you have to do, in the xy plane, r is equal to xi plus yj. Okay, so this I and j are unit vectors, so that, or you can say such that dr is equal to dxi plus dyj. Got it? So now we have this integral c, that is f dr. Okay, so we have this integral c. Now we have to put this value of f, so minus of yi plus xj by x square plus y square, right? And what is dr? Dr is d of xi plus d of yj. Now if we do this integration, so what it will come, so it is c minus of y dx plus x dy by x square plus y square, right? So we change to polar coordinates by putting this x equal to r cos theta and y equal to r sin theta. So changing to polar coordinates, and then what is dx? So dx is minus r sin theta d theta plus of cos theta dr, right? And what is dy? Dy will be r of cos theta d theta plus sin theta dr. Now putting this value in the integral, as we have this minus of y dx plus x dy by x square plus y square, so it is equal to 1 by r square, this bracket, minus of r sin theta minus r sin theta d theta plus of cos theta d theta, and it is plus r cos theta. We have this r of cos theta d theta, okay, plus sin theta dr. Okay, so from here you can get this, it is nothing but r square, so it will be cos square theta plus sin square theta by r square d theta, which is simply nothing but d theta. So for the closed integral f dr, we have this d theta. So this is, let us take this equation as equation 1. Now we have the two cases. So first let us draw figures, that two figures. So this is y and yx. Now okay, so this is the point P, angle is theta, so this curve is C, this point and the x is A, and this origin is O. So this is, take it as case 1. So what is this? So if the origin O lies inside the closed curve, that is C, in figure 1 as you can see, so this is, let us take this as this figure 1. Then for the curve C at the point A, at this point, okay, we have this theta is equal to 0, right? And when after a certain complete round we come back at A, then theta is equal to 2 pi. So from 1 we get C of FDR is equal to theta equal to 0 to 2 pi of d theta, so which is nothing but 2 pi. So this is one of the case, and another one can be this another case, this solution. So we have this, so this is yx is given. So if the curve is like this, okay, so this is a curve, and you can say this point is P. So this is, it may be this not a straight line, so I'm trying to make it a straight line. Okay, so this is one of the straight lines, and this is another straight line, and this is the curve C, as you can identify. So this is C, and this is point P, and this is point A, and the origin is O, which is of an angle of theta. Okay, so this is another figure, and this angle, so this is the total angle is, let us take this total angle as theta. Okay, so from this, this angle is theta, and this angle is theta 0. So this is, let us take this as another case 2. So now if the origin O lies outside the closed curve, as you can see C at the closed curve C, as in this figure 2, then for the curve C at the point A, okay, so we have this theta equal to theta 0. So it is theta equal to 0, and when after a complete round along C, if we come back to A, then it is also the same, that is theta equal to theta 0. So from 1 we get this C f of dr is equal to this theta equal to theta 0 to theta 0 of d theta, and we have theta of theta 0 to theta 0, so it is simply 0. So this is the, so for one solution this answer is 0, and for another it is 2 pi. Okay. So this stands for the question. We have to evaluate this figure, we have to evaluate this integral, the closed integral. So this is the solution for the question 6C. Okay, so in the next video we will see with this 7th, so the question number 7 and their parts.